Hi, would you like to learn Python programming language for free by watching simply on YouTube channel? If you do, please join me at MyWebUniversity free educational videos. And you're welcome to subscribe at our channel, watch these videos and make comments as well as and just put some notes on or kind of like comments to see what areas you need to see improvement for you, so I can make improvement on my videos based on your needs. And if I just sort it by here by the newest, the last videos that I posted, some of them are Python related programming language, and some of them are shell scripting for Unix shell scripting. But I'm adding right now a lot of Python related modules. So this one, Python sys module, was discussed last time, and we're going to discuss more, but there's a lot of Python here, Python PyDoc, and then the Python tips and tricks with Linux command lines, and then you can do the same thing with Windows and then Python import. So without further ado, let's get to the topic of today, what I have for you today. So today we're going to go in the Python language tips and tricks. Let me do a slideshow on this one. So normally I start with this page with the Python language itself, with some of the tips and tricks. Sometimes it's tips and tricks, sometimes it's kind of like branching and if statement, sometimes it's a for statement, sometimes while statement, looping, sometimes functions, sometimes modules. So whatever it is, we're going to discuss. And today I'm going to discuss the Python Lambda function. So we're going to go through the Lambda function, and a Lambda function, as the help of Python interpreter states, Lambda function is basically a small function that is has no name. It's like an anonymous function, and as I put it in yellow here. And then Lambda function has its own definition. So if you use the function definition, the syntax is like def lambda, and then the parameters. This could be one or more parameters, and then the return one expression. The return is just one expression, not multiple expression. That's why it's a small function and it has no name. That's what definition of Lambda function is. Usually you write a small function to just do some computation and you return some result in a memory saver on some calls that you do. As an example here, I'm defining x is equal lambda x, and then return the x to the power of x. So the lambda name is used for the function x, and the result is assigned whatever that expression x to the power of x return is giving to the function x. So when we say type x, it says that it's a class function. But if we just run the x, and then it's going to say, well, this is a lambda function, you want to give it some parameters. And then I say, yeah, I agree. Let me just run like a for statement. In this case, for number in range of 10, print x of number. You can see that it is basically as if I'm just saying print x to the power of x. X to asterisk x is the same thing as calling the x to the power of with parameter number, and the number is coming from range of 1 to 10. In this case, 9 is the last number that it was executed. And you can see that the power to the power exponential, any number with the power of itself, it's growing exponentially very fast. And you see the 9 is really big, and then we can show you some other ones with other activity that are getting much larger. And so I also have a lab activity which I'm going to show you. And you are welcome to test the lab activity before watching this video and see if you can write it yourself. But if you can't, and just I'll show you the lab activity so you can just see exactly what I meant by asking you to do this. So we are asking to write a Lambda function, call it a my function, which takes only one parameter called num, and then returns the multiplier of num times x, basically. And then we're going to call that Lambda function, which is the name is my function, to just double that the variable, whatever we provided to my function num, as num being a parameter, to either double it, triple it, or quadruple it, or quintuple it. Double would do it to the times 2. Triple would be like 3 times that number. Quadruple would be 4 times, and quintuple is 5 times, as you know, those ones. I'm just thanking you in advance for watching, and I will thank you at the end for watching the full video. So at this time, I'm going to show you on Windows platform first, because I want to show you the easy way with Python being so flexible, so nice programming language that it is supported on multiple operating system, Windows, Mac, and Linux. So I will show you at least on Windows and Linux and show you some of the differences in terms of the operating system. But when you go to the Python interpreter, whatever version you're using, it is still going to work. So here, as you can see, I'm just here. I could do a system info and do a pipe more, and you can see that it is basically just a Windows 10 operating system. If I just don't want to see that one, I can also here type in CMD, and by just right clicking and saying open, I can open it as administrator if I want to, but this one I don't need to. So let me minimize this one, and then this one that I just opened is already on this directory of say user Wahid, and then notice that it says I'm on Microsoft Windows version 10. So I don't have to type in system info, but because I had that window open, I ran that one to just show you that I'm on a Windows machine. So at this time, I type in Python 3, it is gonna drop me to the Python interpreter. And notice that is 3.10.5. I can also say, since that is the version, I can, on the previous video, I just showed how to do check on those ones. So you could say import sys and then says dot executable, and then it will just tell you that Python 3 is running on this path. And if I say sys dot version, it will tell me is 3.10.5 is the one that is showing here. Sys dot version info. So this is a quick summary of what I covered last time, but a lot more than that one. I'm just showing you on Windows what are these version information, and then on a Linux machine as well. Later on, I could show you, so you could see that Python is so portable. When you write the code, it is not an issue as long as you use the right version of Python that supports it. Python 3.6 and up usually has this mechanism. You can do it. So let's just go with the first example of that program that I did here. I believe it was just this one. X is equal lambda x to the power of x, and then do that one. So I'm going to do here, I'm going to say x is equal lambda, and then x, and then x to the power of x. So this one is basically, if I say type of X now, X is a function, but if I run X, as you see it, it says it's a Lambda function. So Lambda function meaning that I could just say X of 10, I could just get the number X 10 times 10 to the power of 10 actually, because we did the power of here. So if I do X of 2, it's gonna just give me that number. And if I say X of 5, 5 times 5 is 25. I mean 5 to the power of 5, not times. Times would be like this, 5 times 5. That's 25, but 5 to the power of 5 is going to be just giving you 3125. So now I'm going to just show you the X. Since the type of X is a Lambda function, I'm going to just say for num and range, and then I'm going to try the same number that we tried there, and then I'm saying print X of num. So this one will just run that function, and it will produce this one. I could also do the same thing here. I didn't need a Lambda function. I could have just said print, and then one inline things like num to the power of num. That would produce the same output as above. So whether you are using the Lambda function or inline kind of syntax, this is also anonymous. It does not have a name. We're using this. So we could do that one. But at this time, I'm going to try one more time with a bigger number. For this one, let's say I'm going to call it like 20. 20 is not that big, but it is still going to just generate a larger number. So print X of num, and then num times to the power of num will be the Lambda function will compute, and you can see it is growing bigger. Now, if I just change this one to 50, which is like a larger number, 50, and then say the same thing here, print X of num. Notice how big the number went through this. So you could say X of 100, and then this number is really huge. And this is, look at how big it is. And if you do some number that is not all zeros, like 555, then, oh, that's a big number, 555, and that's, you can see it's almost the largest number that you can store there. So, I mean, depending on what you pass in on and you take a power of it, exponential grows really fast. So that was one example. And then on the same time, I'm going to just go to the second one, which is, let's try the, this one, we say, let's try the Lambda function, call it my function, which takes one argument as a num and then multiply it there. So let's go back to this one, and then the Python interpreter is already open on the right one. So I'm going to say import. Actually, I could just do it simply here, print, and then say new line character, and then times 50. So this would quickly clear my screen for me so I can type in nicer here. So at this time, I'm going to write a function. And the function, you normally say def, and then I name it my function, like as we said it in there. And then it takes an argument num. So I'm going to say, that's the function name. I move 4 characters to the right, and then I indent it, and then I just say return. And then at this time, I'm going to say lambda, lambda, and then x is the name of the function. And what I'm going to do the expression is x to the power of x. That will just be returning. So now that my function is defined. So if I say type of my function, this one is a class function. But if I just say my function by itself, it is going to say it's a lambda function. You can see function, my function at this address. So this is basically a function at this address. Since we actually, this is not lambda. This is what a lambda function is, because we use the lambda in front of it. And this is anonymous. This has a name. It cannot be a function. Sorry, when I mentioned this one is a function, I meant the lambda x is a anonymous function. So when we do dir here, notice that the name of the function is here, as well as the x is there. So if I just say type of x to see what is x, x is a function. But if I say run x, now it says x is a lambda function. So that's what I meant earlier when I did it there. So now we have defined these values. Let's just use it. Num is not defined here. At this time, it's 49 by default, a number there that last time maybe it was on the memory. So I'm going to, if I just say x of 10, obviously we'll just do that 10 times 10. 2 times 2 is 4. So x times 3 is going to be 9. So, and then, I'm sorry, 3 times 3 times 3. So that would be 27. And then x of 5 would be 5 times 5. It's going to be like 625 maybe, or a larger number. And so x of, and then that's like same thing as printing. Last time we did 5 to the power of 5. And similarly with 3 times 3 for the x expression, it would be 3 times 3 times 3. And that would be 27. And then similarly, if we do print x of 3, that would also be printing 27. But what I want to do at this time on the documentation here on the presentation, we said on the second part, once you define the function, let's use double to double it, another function, and then assign that function to double, and then quadruple and quintuple. So let's do that part. And here now we do again dir. So the name is my function. I'm going to just say double. I could say doubler is equal, because double is already might be the system defined function or something. You want to make sure that it's not there. My function, you could just say 2. So now doubler is there, and then we want to do tripler. Tripler is equal my function, and then we want to do it 3 times. And then the next one was quadruple is equal my function times whatever you name it. You have to do it multiply to the power of that. So that's quadruple is going to say my function to the power of 4. And then so the quintuple is the next one, which is the power of 5. Quintuple is equal, and then we say my function is equal 5. So now we define it. There of these variables are also there. You can see that is there. So if I say doubler is going to say doubler of what number? So doubler of 2 is going to be 4. Doubler of 10 is going to be 20. I'm sorry, 10 to the power of 10, which is printing, not times. So 10 to the power of 10. That would be equivalent to the number above. And so if I just do double of let's say 5, and that was like doubler of that one was 5 to the power of 5 was 31 something, 25, and then 31, 25. And then now if I just do a tripler of 3, it was 27. 3 times 3 times 3, that was the 27. And then this would be 5 would be 125 tripler. So I'm sorry, 5 was again, that number is big. So on 3 times 3, let's do a 4 on the tripler. See, yeah, 4 times 4 times 4. So this is like saying to the power of 4. That is huge number to the power of. But if we just do times 4, it is oh, because I'm using the tripler. Sorry, the tripler is going to just make it like kind of a nested a multiplication, as if like recursive one. So, and instead of, this is what I meant to write, a print and then 4 times to the power of 4, which would be like 256. Yeah, that's what I meant earlier. I'm just forgot to type in print, and I typed tripler. So sorry about that. And then the quadruple, we could just say, for example, make a 3 to quadruple, and then we could see that's and there. And then for 2 is also gonna make it a 4, and then same thing with 5. It's going to get it huger. And there, quadruple. And did I just do the quadruple correctly? So quad, I think the function definition of the call, I might have wrote quadruple incorrect. So I meant to say for quadruple, I wanted to do just basically my function and then 4 times 4. So this would, sorry, my function, I just have to type in F here. Oh, the insert is not on, so let me just correct that one. My function and then 4. And now call the quadruple here. Quadruple of that one, yeah, that one is now accurate. And then for 2 is 2 times 2. Yeah, 2 to the power of 2 is just we got the same thing as 4. Okay, so and then quintuple is the same thing. So quintuple of let's say we get a 5 there. My function, I have to give my not my function, actually that's all we need is there. Quintuple looks like it is all doing to the power of, yeah, exactly. So the larger number it is there, it's gonna get bigger. But I think maybe on the definition, let me go up here to see what I define on this definition. 2 times 3 times 4, that's okay. Yeah. As long as we pass in the right number of argument, then 5 times that number will be multiplied to that power. And then we could just do the same thing for like another function. Let's just try the quick function of Lambda. I'm going to say print new line character, and then times 50, and then I'm going to just say x. Let's just write a Lambda function, call it Lambda a comma b, and then we're going to return and we're going to call it just actually let me just do x to the power of y. So, and we have in mathematics, we have f of x is equal y squared, right? So if we want to do any number that we provide, if we provide y minus 2, it would be 4. If we provide y is equal to the power of 2 is 4, and 5 is 25, and 3 is 9, so on. So let's write that function. If we just say x is equal, we could call it f for function. We could say f is equal lambda, and then we could just lambda, and then we could just say then variable that we want to pass in was y is equal y to the power of 2, to the power of 2. That would be whatever number it is going to just bring it to the power of that number. So now we define this one. Actually, when you do it now, you don't put the equal sign, you put the expression. So y to the power of 2. This is now defined, and then type of f, we're going to get this one, say that is there. F is the lambda function. So f of 2 should give us 4. F of 3 should give us 9. And f of 5 is going to give us 25, and so on. And so we could just quickly say for item and range of, let's say, all those 10 numbers, 0 through 11, actually, so including the 10, when I put 11, I'm including the 10, say, and now say f of print f of that number, and that number is item. Whatever you use that variable, you're just basically getting the multiplication of it. So that's enough for the session of Windows. Let's just get started with the Linux. So you know the power of Linux is the same on this one. I'm not going to show everything on the command line. We could just actually write a program to do this one, and then we just call it there. But the program is the same. So let me just make this screen there. And as you can see right here, cat etc/os/release. I'm on a Ubuntu Linux long-term support. And if I clear my screen, type in uname-a, it will just say I'm a Linux machine. If I say which Python 3, it tells me that I have Python 3, and then Python 3-v for the version. I could have done the same thing, -v for the version on Windows. If you just are here, exit out here, and then type in Python 3-v, it will tell you that the version is Python 3.10. Here is the 3.810. So it's a little bit older than the 3.10 that we have on Windows, but I could use all of them. It's good. So Now I can say Python 3, and then automatically drops to this one. I'm not gonna go again to import sys, which I did, and executable. You can see that same thing, sys.version, sys.version info. So whatever works there is here, sys.ps1, PowerShell, sys.platform, which is Linux. And here, when we were on Python, if I was typing Python 3, and then I could say sys.platform, and notice this one is not showing that. I'm sorry, I have to import sys first, and then sys.platform. Then it's going to say Win32. And then if I say import OS, and then os.name, notice is NT. And then on the Linux side, if you do sys.platform is Linux, if I say import OS and then say os.name, it's going to say POSIX, because on Linux and Mac you get POSIX, and then the Windows you get a new technology, which is NT, that replaced Microsoft Windows 95 FAT file system, file allocation table, FAT32 in 16, 32-bit, and 64-bit. So it is NT, the new technology, Windows NT, and that version was introduced long time ago. So here os.name is POSIX. So I'm going to just say os.system. I'm going to clear my screen rather than doing that statement. I could have just, since I did load os.name, I could do that one. Similarly, here I could do os.system. Earlier we were just using the printf statement inside. We could do this one if it is there. Since clear is the Linux command, CLS is a Windows command, and that will clear the Windows command. You have to type in os.system and then the command of the operating system there. So for example, here os.system is Linux. I type in uname -a, and that would type and give me the operating system information. So let's go back to the Lambda function. Here I could just write the Lambda function, for example. On this case, I'm going to just write a quick function using less comprehension. So with less comprehension with Lambda function, you could just say, for example, I could say x is equal, and then just write x, a short form for x in range of 10, and then just that would just print x with those 10 numbers. But then if I just change this one to 100, and then if I say fx mod 5 is equal 0, then any number that is between 5, 10, 15, and other ones, I'm interested. So you could see 5, 10, 15 in there. And then at this time, if I just want to do an inline Lambda function, you could also use this formula here. Whatever you wanted that expression to return, you could say x to the power of x here. So whatever that number is, this is huge. So if I just say x now, look at how big it is. So in order to just make this one smaller, let's just do between those two, and then x is now only those two numbers. The first one was 1, and the second was 5. If I want to just go to a little bit more than just that, look at 20. So I will cover 10 and 15 as well. And now x is there as just a larger number. So you could do an inline function like this also on Lambda function with less comprehension. Another way we could just write it program and get out of the pie chart. And then since I'm on the Python directory, I'm going to call a function, my function. So them, and then I'm going to say my function.py. So I name it .py, and since I'm using Linux, I'm going to say user ben env, and then in this case, I'm going to environment load the Python interpreter, and then here say just to test the function calling Lambda function. So and then right here to just test it, and here we are going to say my def my function, and then here we just say the parameter there, and then on the my function at this time I'm going to say return lambda and then x, and then x to the power of num. That would be the function. Then I say doubler is equal my function, and then call it times 2. So that is the num that I'm passing the value, and then 2 times whatever there, and the number is there. And then the next one, I'm going to say tripler is equal my function, and then we call it times 3, and then quadruple is equal my function times 4, and then quintuple is equal my function times 5. Notice since I have a typo, this the character is longer, so I'm going to do this one. And then here we could just say print just a couple of testing. Say print doubler of same number. We're going to say let's get the doubler of 5, which we know that was a bigger number, 5 to the power of 5, and there. But this time I'm going to just and instead of doing a larger number exponential, I'm going to say times that one. Whatever number it is times 2, times 3, times 4. This is much easier to just say if I want the x to be 5, then 2 times 5. And then if the x is called with other one, which is called tripler, then 5 times 3 times 5. And then let's call the other one, we call it 4 times, which is 20. The 3 times would be 15, and 2 times 10, so quadruple. And then the last one is 25, which is quintuple. So let's see if I'm right on those number. I was just guessing as we went through. Now my function is there. If I say file my function.py, this is a Python script. So it is not executable yet. I just can only run it with Python 3, and then give the name of the function my function.py, and that would just give the exact values, which is correct. So my function.py, as you can see, it was saying that when it is 2 times 5 is 10, 3 times 5 is 15, and 4 times 5 is 20, and then 5 times 5 is that. So if I just run the same program, you can see this the statement was okay with it. And then the other thing we could do is change mode u plus x for my function dot py, and then dot py, and then we just say ls minus ld my function dot py, and then here I have the executable set, so I don't have to say Python, because on the first header line I wrote it like that, so I could just do it that way. And then we can also read the argument from the command line, and that way we don't have to hard code it there. And the first video that I did, sysargv, we did that way, and then we could just do it similarly here by importing it. Let's just do it with a thing and then see if we can take advantage of that video as well. My function.py, so I'm going to say here on this one, and then I'm going to just say import sys, and then here we're going to say sysargv sub 1. So we're going to say sys.argv sub 1, whatever number we provide here, and then we're just going to call sys.argv sub 1. And then the testing we can do also, and that it has to have at least one argument. But on that video, it is there. I don't want to make this video so long and do validation and other ones. So if you have to just test for the validation of the sysargv, requires at least 2 arguments in this case, which is the name of the program, which would be sys.argv sub 0, and then the parameter that is passed here is there. So we could just do this. Let's just save it and then say run the same program here. And then if I just don't provide any input, it's going to complain. But if I just say 5 again here as argument, it's going to just do those ones. But notice that since this argument is read as a string, it just does that string that many times. So it concatenates that one. In order to correct it, you just have to convert this one to the end type. So you could just say end, it's a casting of this one automatically. And then, so I could just do this one in the vim, since I'm here already. I want to just do it in one shot rather than modifying it there. Let me just take this one, okay? And then from line 14 to 16, so I'm going to say 14 comma 16. That's the power of you know, Linux and vim and other things that you can take advantage of it. So you could just say whatever is this argument, I want to just change it to end, and then this argument followed by another bracket, and then this. So now I'm going to say globally change it. It did not change it. Let me just see why. So 14 comma 16 substitute. I'm going to just say sys. Oh, because these arguments sometimes when it is there with multiplier and this dot means a special character. So we're going to skip it, and then we say substitute that one to end, and then type that, and then just substitute this one to a special character because we're going to skip it. And then after that one, we're going to close it, and then just do this, and then that. It did not do it. I'm going to do it quickly here. I thought that we could just use the skip sequence on the regular expression, but it did not match it. It is not that many. I'll just do it quickly here. And one more, and then sometimes you can use the dot to just repeat the same thing, but I could also I missed the one more parameter. So this one is end. Actually, this. Let me just make sure the number of parameters that are closing is enough to close. Yeah, there. So now we run the same code here, and then notice that the 5 this time is accurate because we converted to an integer and there. So if I change now that 5 to 10, then it would be 10 times 3 times 10 would be 30, and 5 times 10 would be 50. And if we just change it to 100, it is all dynamically read from sysargv. I'm not gonna do for validation, but if you run the program like this, it says, okay, you have to make sure that it's not out of range. And let's just do that one to make our program complete. So, and then the name of the program was my function. So vim my function.py, and then we say right here, and we say if sys.argv.length underscore length is less than 2, then say print please provide at least one value. So you could even say, like, for example, print, and you could just help the user to say name of the program in this case, which is my. You could even call it, like, for example, the name of the program. If we just say sys.argv sub 0, that would automatically know that the name of the program, and then we're gonna say the value next to it. So the value would be like an example would be, and here would be a 5, for example. And then so in order to display 5, we're going to just type in 5 here, and that would just be like the sysargv and then 5 and then this, and then we could just also say here and within the code example, and then here do that. Let's see if that is there, and then if it is not there, you say exit. So it exits it, and else you just do all this thing for that one. But when we do else now, since we wrote the definition of the function, actually we don't need to do else part because all of that one is within that block. Otherwise, I have to adjust again. So this one is good enough if you just do that one there, and then we could even move these lines in front of the print statements. So it will just check on it 1, 2, 3, 4. So I could just say the 4DD here and then print it on line 13 here. So I could just do that one, and then here if it doesn't exist, then we are just going to make those calls. So the program should work with our original test, and then that is not working. Method end wrapper not supported. Okay, so the less than sign was not recognized here. Let's see why. So we say if this is less, because we are just saying argv sub, if this one, we're going to get the length of this one and then compare that with and this less than this. So if a length of it is, which is sys.argv, whatever the length, and that number is going to be just now accurate, because the length was the double underscore length. That's the magic method. It was saying this instance is a wrapper. So we use the length function, which returned the number of argument that was passed, and then we just do it. If we don't do this one, it's going to say that please provide at least one value, example my function.py, and then since I say $argv sub 0, it wrote the name of the program. And then the second argument, we are saying that at least it gave one function like this, 5, and it should work. So if I just gave another number, it's still dynamic, but this time, if I don't give the enough argument, it will fail. I mean, it will just help us say that you provide the wrong number of arguments. Obviously, if you don't check for more than that, and then you say, now sys.argv sub 2 has this value, since we don't do anything with it, it ignores it. But normally you want to just say, if there's, I'm not expecting more than one argument, you could just say, if the argument is less than 2 and greater than 2, and then just say, please provide one argument. So you have to be more descriptive on the definition. I hope you enjoyed this video, and this video was just for Lambda functions. Please make sure you subscribe and like our videos and make some comments. The comments is very important, that if you want me to cover something that I haven't covered, or something that you want to do on Python, on shell scripting, Unix, C, C++, I will cover all those ones based on your needs. Otherwise, I don't want to make videos that nobody watches it. So it has to be helping you to just improve your kind of life for your job and for your school, something that support you better. Okay, have a great one. Thanks for watching. God bless you all.